before I give my solution. Just pause the video, give it a shot, and now I'm going to give my solution to that. So let me back out here. I'm going to say the following. I'm going to say that the pressure in chamber B plus the pressure due to the mercury is going to be equal to the pressure in chamber A, because there are two things that are fighting or holding back that push down from chamber A. It's the pressure in chamber B plus that little bit of mercury. So alternatively, we can say that the pressure in chamber B must simply be the pressure in chamber A less the pressure that is contributed by that mercury. So we already know this guy. That's known. All we have to do is figure out this. So whenever we're trying to find pressure due to something like a liquid level height, whether it be mercury or water or whatever, we need to do just one simple thing. We take the pressure, we'll do it in red, the pressure of the Hg, it will be equal to the density of mercury multiplied by the gravitational field constant in wherever the measurement's being taken, times the height of the mercury column that you've got there, that amount of mercury that's standing up above. And it's really interesting to go back and check the units on this. You'll see that if this is measured in kilograms per cubic meter, and this is in meters per second squared, and this is in meters, we get a unit that is kilograms meters per second squared. Excuse me, let me restate that. I said that backwards. I got my meter in the wrong place. Kilograms over meters a second squared. That's equivalent to newtons over square meters, which is the same as pascals. Okay, so we know that this is a pressure unit. So what are we going to do? We're going to take a look at this. In the problem, we're given the following. We're given that it's 900 millimeters of mercury, and we are not given density or the density or the gravitational field constant, but from question 1 in this exercise, we used two values. I'm going to reuse those values. We're going to say that density from the first question that we did was 13.59 kilograms per cubic meter. Excuse me. That is grams per centimeter cubed. And G will be equal to 9.81 meters per second squared. Okay, let's carry on with this. Let's get the pressure of the Hg column. So the pressure of the Hg looks like this. It's going to be equal to 13.59 grams per cubic centimeter. We multiply by 9.81 meters per second squared, and we multiply by 0.900 meters of mercury, and that would be your 900 millimeters. But I have to put in a couple of conversion units. I need to convert the grams to kilograms, so I've got 1 kilogram per 1,000 grams, and I have another conversion factor in there, which is 100 centimeters per 1 meter, and that's to offset this. And then we look at this centimeter unit and we say that's cubed, so I have to cube that conversion. All right, with that all said and done, let's get this into our calculator, and let me I've got my calculator in hand. I don't have one for the screen, so I'm going to say 13.59 times 9.81 times 0.9 times 1 over 1,000 times 100 cubed. in doing that, I end up with an answer that's 119. This is 119,986, and this is going to be in pascals. So now, if we want to get the pressure in B, it's very straightforward. We're going to use our answer from A. The pressure in B will be the value that we got for A. So let me just have a quick look up here. What was that value we got for A? It just worked out to a nice even 400,000 pascals. So we have 400,000 pascals less the 119,986 pascals. And again, this was the absolute pressure. This is the absolute pressure in A that I'm using. So when I subtract this, I'm going to have the absolute pressure in B. And so let's take 400,000 and subtract that. And we end up with 280,000 pascals. That's just a rounded number. Now, recognize again, that's absolute pressure. So in atmospheres, this is PB absolute. PB absolute is 280,000 pascals times 1 atmosphere per 101,325 pascals, and that works out to about 2.76 or 2.8 atmospheres. Now remember, that's absolute. So if we want this answer in gauge, PB gauge, well, PB gauge is just the amount over atmospheric. So PB gauge would be 2.8 atmospheres less 1 atmosphere, which is the pressure of the surroundings. And we get, 100, my apologies. The local barometer reading's 100 pascals, 100,000 pascals, my apologies. So what we're going to do is take 280,000, and because it was 1 bar, the atmospheric pressure was 100,000 pascals. That was our 1 bar. So we've got 280,000 pascals less 100,000 pascals. We've got 180,000 pascals. So now, what is our gauge reading? Our gauge is reading 180 kilopascals. That's what they wanted the final answer to be in, 180 kilopascals. And the absolute pressure is 2.8 atmospheres. I think that covers everything. Hopefully that was helpful. And please, I apologize for some of the errors I made in my communication there.